Okay, so now we're going to be taking and counting things from different sets. Mutually disjoint means these sets do not overlap. And if you add up all k of them, 1, 2, 3, 4, all the way through k, then you get the whole set A. Okay, so let's look at this question. How many 3-digit integers are divisible by 5? Hey, wait a minute, we did this already, right? I'm going to show you another way to do it, and why we'll need it need it to do other kinds of problems. But this, you could think of, hey, I have 3-digit integers, so 5 times, 5 times 20 gives me 100, so that's the first 3-digit integer, and then I want to go all the way to 999. Well, I'm not going to 1,000, right? So that means I'm not going to 5 times 200, so then the last number that I want to keep my numbers here, so 999 all the way here. The last number I want is 5 times 199. So then now I want to count the numbers between 199 and 20, add 1 to include their endpoints, and that's how I get 180. Okay, so another way to do this same problem, and we're going to need it for this when we have distinct digits, is to think about 3-digit oops, let's make that line a little straighter. 3-digit integers, and I'm going to say, okay, we could end in a 5, or we could end in a 0. Okay, so if I'm looking at ends in a 5, then there's one way to do that. Then this digit here, it can't be 0. And so there's 9 choices there. And then this could be anything, so there's 10. Now this one here, the 0's already been placed here. And so I just have to say not 0 again. So there's 9 choices. And then there's going to be 10 choices here. And there's 1 choice for that. And that gives you the same number. All right. So let's go with distinct digits. So you cannot use this method because you got to worry about where the digits are for each of the cases. Okay, so divisible by 5. That means I'm going to have ends in 0. So I'm going to put my four-digit integers, right? So I'm going to put the ends in, I'll put the 0 here, or ends in a 5 here. So distinct digits means no repeats, right? So if I have a 0 here, there's one way to put the 0 here. And then I have to say, okay, whatever, I put the 0 here, so I have to say, okay, you can't put 0 here, and that gives me 9 choices. And then I've used 2 digits, right? So I get 8 left, and then times a 7. All right, so if I put the 5 here, there's one way to do that. I have to say not 0 or 5 here, so there's 8 left. I've used 2, so there's 8 and then 7. Okay, this 4-digit integer, I want to put the digit 3 in once. Well, of course, you wouldn't get a hint like this on your test, but I want to think about putting the 3 in each of the digit places. So I'll start with putting the 3 here. Or, oops, I could put the 3 here. There we go. That is very messy. Let me fix that. So, or, okay. Okay, so, or I could put the 3 here. Or, no, I put it in the same place. Okay, little challenges here. Okay. So I could put the 3 here, or I could put the 3 here, or 1, 2, 3, 4, I could put the 3 here. Make a little division line between those. Okay, so now I'm off to find out how many places, how many choices I have for the other digits. So there's 1 choice to put the 3 here, right? So put the 3 here. Good. Then doesn't say anything about distinct, right? So I only want not 3. So to have not 3, in each of these cases, then I have 9 choices. Okay, so I'm putting the 3 here, 1 choice for that. So I have to pick something here where it's not going to be 0 or 3. So I have 8 choices here. And then not 3 and not 3 for these two. That gives me 9 choices for each of those. 1 choice here for the 3. Again, not 3 or 0. So that gives me 8 choices. I have 9 choices here and 9 choices here because these just have to be not 3. One last one. I'm putting the 3 here. I have 8 choices for this digit because it's going to be not 3 or 0. And then I've got 9 choices here and 9 choices here because these two are not 3.